Finishing up with the review, we have questions 20 through 25. Okay, the first couple ask us to find the perimeter of each polygon. Here I have a triangle XYZ. Where I need to figure out the length of each side. Remember that perimeter is going around the outside of any particular shape. In order to find the distance, it looks like I have some various points on the coordinate plane. So I'm going to have to make use of the formula distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? x2 minus x1. Well, let's take a look. -1 subtract 3. And I square it. -5 subtract 7. And I square it. Don't forget to bring back the square root sign. -1 subtract 3 is -4, and I need to square. -5 subtract 7, -12 squared. Now remember that whenever I square a negative, squaring a negative ends up with a positive. So I have 16 plus 144. Okay, 16 and 144, I have the square root of 160, which I can simplify further on my calculator. Okay, so this is the distance for x, y. That gives us one side. Now I need to do the next one. Y, z. Okay, y, z, we still use that same formula. 6 subtract -1. 6 subtract -1, and I square it. -4 subtract -5. And I square it. 6 subtract -1 is 6 plus 1, that is 7 squared. -4 subtract -5. This is -4 plus 5, so this ends up being 1 squared. Bring in the square root. 7 squared is 49. 1 is 50. So our final answer is the square root of 50. Okay, once again, you can make it a decimal in your calculator. YZ. So we have XY, YZ. We're left with our final side, XZ. I need to know this as well. So square root 6 minus 3 squared plus -4 minus 7 squared. 6 minus 3 is 3. -4 subtract 7 is -11 squared. We now have 9 plus 121. So this is the square root of 130. Once again, you can change that into a decimal from your calculator. So to find the perimeter, my perimeter is the square root of 160 plus the square root of 50 plus the square root of 130. Add those all together in your calculator and you get your final answer. Rectangle PQRS. Well, this is a whole lot simpler. I don't have to go through nearly as much math. In this case, I think a diagram is going to help us quite a bit. okay? Because it looks like everything is going to be very easily on the coordinate plane. I'm going to draw an X and a Y axis. Okay? Vertices, P is at 0, 0. This is letter P. If I count up 7, I'm at X equals 0, Y equals 7. 1, 2, 3, 4, 5, 6, 7. This here is point Q. Point R, if I count over 12 and up 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, here's my point R, and S is 12, 0, 12, 0, Y, so this is my S. Everything is along a particular horizontal or vertical, so we don't have to use the distance formula. We don't have to find any diagonals. All we need to do is count along the number lines. Okay, here the distance between P and S is 12. The distance between P and Q is 7. And we know because this is a rectangle that this is also 7 and this is also 12. I could say for the perimeter that it's 2 times length plus 2 times the width. So that's 2 times 12 plus 2 times 7. Or if you're more comfortable just counting your way around, 12 plus 7 plus 12 plus 7. Either way works. 24 plus 14. The perimeter in this case is 38. Okay, so now on to a word problem. Our word problem asks us to find a new radius. Okay? We have a severe weather siren that can be heard within a radius of 1.3 miles. The city wants a new siren that covers double the area of the old one. And we need to determine the radius of the new siren. And it tells us to round to the nearest tenth of a mile. Well, in order to figure out double the radius, I need to figure out what is double, we'll cover double the area. I need to figure out what is the area of the old one. Okay? Area for this old one is going to be pi r squared because that's the radius for a circle. Okay, what we have here is a siren in the middle, and we know that has a radius of 1.3 miles, and it can be heard anywhere along within that circle. Okay, so my area is pi times the radius, which is 1.3 squared. This is 1.69 times pi. I'm going to leave it there because I think that's going to help simplify things for us as we move on to more of this. So this is the area of the old siren. The area of the new siren is going to equal twice the area of the old siren. So that's going to be 2 times 1.69 pi. Okay, that happens to be 3.38 pi. So we have the area for the old, we have the area for the new one. How do I determine the radius? Well, I just work backwards. I know that my area is pi r squared, regardless of the circle. And our current area that we need it to be for the new siren is 3.38 pi. Divide by pi on both sides, and I'm left with r squared equals 3.38. So r is equal to the square root of 3.38. Okay? And that, of course, is going to be 1.69, I believe. Oh, actually, I have that incorrect. 3. Plug this into the calculator. Square root 3.38. That's looking a lot better. 1 point, and we need to round to the nearest tenth. The nearest tenth is 1.8 miles. 1.8 miles is the new radius that we need to have, rather than the 1.3. We need a half mile further. Okay, so we're on to the final questions. 23, 24, and 25. And all of these have to do with a 3D figure. Okay, what kind of figure do we have? In this case, we have a pyramid. Okay, in your Google Classroom, you will see immediately with the online textbook, I have posted at least the first formula sheet. I intend on amending that and including all the different formula sheets and postulates from throughout all the units of geometry, but for right now, this is all you need to worry about for the test. You have a copy of these formulas that you may use for the test, because there's no way that you're ever going to memorize all of this. Okay? So what we have here is this regular pyramid, which can be found also on the formula sheet. The first thing it asks us to do is to name the base. Well, I have one base, that's outside at the bottom, and I have 1, 2, 3, 4 faces. The base is L, M, N, O. Okay, to determine the surface area, I need the formula. Okay, surface area is 1/2 times the perimeter times a side length plus the area of the base. Because what we need to do is we need to figure out the area for each of the 4 triangles that are our faces plus the area of the base. Okay? So what this gives us, remember that this is the perimeter of the base, and this is the area of the base. And then L is our slant height. Okay, we're not looking for how tall this point is, we're looking for this slant. We want to know how long is that slant. Okay, so how do I determine the perimeter of the base? Well, this one happens to be square. I have 10 centimeters by 10 centimeters. So I could take the 10 centimeters and add them all up. Or I could say, hey, I just need to take 4 times the length of one of the sides. And I know that that is 40 centimeters. So that gets plugged back into here. Okay? Right now we know that S is equal to 1/2 times 40 Now what is the height of the slant? How can we determine that? We know this. Oh, here it is right here. From this vertex along that face to the base, we see this perpendicular? That tells us that the L, or slant height, is 13 centimeters. So we can plug that one in as well. Okay. 1/2, 40, which is our perimeter of the base, slant height, which is 13. Now I need to know the area of the base. Okay. The area of the base is length times width. Because once again, we have that rectangle or square. Area is length times width. Okay, my length in this case is 10. My width is 10. And so my area is 100 centimeters cubed. Now, will my units work out okay? Well, this here is 40 centimeters, this is 13 centimeters, so when these are multiplied, this is also centimeters cubed. 40 times 13 divided by 2. I'm left with 260 plus 100 centimeters squared. So my surface area is 360 centimeters squared. Well, that gives me the surface area. I have the base and all four sides. How do I determine volume? Okay, volume is actually a little bit simpler. Once again, we have to find the correct equation. Okay, so the equation that we're looking for volume of this pyramid is 1/3 area of the base times the height. Okay, this capital B is area of the base. Okay, 1/3. What is the area of the base? Well, that is length times width. So that's 10 times 10. My height is from P down to the middle of this base. That is 12. 10 times 10 is 100 times 12, 1200 divided by 3. Let's check on a calculator. And our answer is 400 centimeters cubed. Surface area is like your wrapping paper. Okay? A surface area, like an area rug, or like wrapping paper, that's going to be centimeters squared, 2 dimensions. Volume, 3 dimensions. Length times width times height. So we have centimeters cubed. That is everything.